Today's video I would like to introduce you a very nice problem of Canadian Mathematical Olympiad edition 2009 question number 4. Here is the following setup. Find all pairs A and B such that we have this condition: 3 to the A plus 7 to the B is a perfect square. Okay, in the other word, we are going to find the appropriate values of A and B which makes this whole term as a perfect square. Okay, the most important hint that I'm trying to give to this problem, you are going to use a power of 3 and power of 7. Okay, so you are going to make this expression on the form of the product and involving the congruence as well. Okay, and then we have to check some point. We have to check the obvious cases where we have the perfect square for 3 and 7. Okay, go ahead, pause this video if you would like to give the try to this problem. When you are, come back to see the full solution. Okay, let's get into the solution now. In order to have this term as a perfect square, we must write this expression on this form: 3 to the A plus 7 to the B equals x squared. Okay, now I'm going to reduce this one to mod 7. So I'm going to check where we have the perfect square when we use mod 7. Okay, let's put 0 square is a congruent to 0 mod 7, and 1 square is a congruent to 1 mod 7, and the third term 2 square, which equal 4, is a congruent to 4 mod 7, and we have 3 square equals 9 is a congruent to 2 mod 7, because 9 is 2 more than 7. Let's check the another term. 4 square is equals 16 is a congruent to 2 mod 7, because 16 is 2 more than 14. Let's check another one. 5 square equals 25. 25 is a congruent to 4 mod 7, because 25 is 4 more than 21, which is 4, which is 2 square mod 7. Now we have a perfect square in number 2 here. Okay, let's check next one, which is 36. 36 is 1 mod 7, because 1 more than 25. Okay, let's check the last one. 7 square. 7 square is a 49, is 0 mod 7. Okay, so if you check here, we have 0 and number 1 and number 2 are the only perfect square mod 7. Okay, so number 0 and 1 and number 2 are. Then I'm going to reduce this one to mod 7. So I will have 3a is a congruent to x squared mod 7. You might say, where is 7 go? Because since b is a positive integer, we have 7 square, we have 7 square, 7 to the 3, 7 to the 4th, and so on and so forth. That's mean this term is a multiple of 7, so this one, it will be cancelled out, it will be 0. Okay, so I will be end with this expression. Now we are going to check where we have the perfect square. We have perfect square at 0 and 1. We have perfect square at 0 and 1 and number 2. So I will be write 3 to the A is a congruent to 0 mod 7, and I will have 3 to the A is a congruent to 1 mod 7, and also I will have 3 to the A is a congruent to 2 mod 7. Okay, this one it will be eliminated because 3 not divide, because 7 not divide 3, because they are different prime, 3 and 7, and also this one it will not work because 7 not divide 3 to the A, because 7 not divide 3 to the A minus 1. Let's take an example. If you replace A with number 1, I will have 3 minus 1, which is 2. 7 not divide 2. Let's check A equal to 2. Equal to 2 is 9. 9 minus 1 is 8. 7 not divide 8. Let's check A equal to 3. 3 to the 3 is 27. 27 minus 1 is 26. 7 not divide 26. So this one will not work. This one will not work as well. Okay. So the only one who works this one. Okay. Now this one will be broken into two cases. When we have a is an even number and when we have a as an odd number. Now I'm going to check first with odd number. If a is an odd, that means a will be replaced with 2 n plus 1. I'm going to replace this one into here. I will get 3 to the a equals 3 to the 2n plus 1, which equals 3 is multiplied by 3 square to the n. Okay. As we know, 3 square is a congruent to mod 7. This one will be replaced with 2. 2 is multiplied by 3, which is 6. It will have 6 mod is a congruent to 6 mod 7. This one is different than congruent to 1 mod 7, because to have a perfect square we must have this one. 3 to the a is a congruent to 2 mod 7. We have 6 here, which is not working. Okay. Since a is not odd, that means a is even though we are going to check it. Okay. If a even, that means a equals 2n. I'm going to replace a with its value. I will get 3 to the a equals 3 to the 2n. I will have 3 square to the n. As we know, 3 square is a congruent to mod 7. Okay. So which is correct? Which is working? 2 mod 7. 2 mod 7, which we have here. Okay. That means this one is okay. Now a is even. Now I'm going to replace a with its value. I'm going to replace a with 2n because it is even to check the next case. So you have 3 to the 2n plus 7 to the b equals x squared. Now I'm not going through the congruence because it's a long way. I'm going to use a trick. I'm going to suppose, because our goal, we are going to check the parity of b. Maybe b is odd or b is even. Okay. So I'm going to assume b is even. If b is even, then we work at some point if we find a contradiction, and that's mean b is not even, that's mean is arithmetically is odd. That's what I'm trying to do now. So by the way of contradiction, suppose b is even. B is even, that's mean b equals 2m. Okay. Now I'm going to take this value and insert it into the original equation. I will have simply 3 to the 2n plus 7 to the 2m equals x squared. Okay. Now I'm going to take 7 to the 2m to the right hand side of this equation. So I will have 3 to the 2n equals x squared minus 7 to the 2m. So since I have the difference of two squares, I'm going to factor out this one. I'm going to make the product by factoring out this one. So we'll have x minus 7 to the m factor x plus 7 to the m. Okay. Since 3 is a prime number and the left hand side of this equation is a power of 3, that means the right hand side of this equation must be a power of 3 as well. So that means this one is going to be written on this form. So we'll have x plus 7 to the m equals 3 to the j, and with the second equation it will be written as x minus 7 to the m equals 3 to the I, whereas j is bigger than I, because this term is a bigger than this term, as x is a positive integer. Okay. So now I'm going to eliminate x from this equation by subtracting equation number 2 from equation number 1. I will get 2 times is multiplied by 7 to the m equals 3 to the j minus 3 to the I. by taking 3 to the I as a common factor, because I is smaller than j. So we'll have 3 to the I factor 3 to the j minus 1 minus I minus 1. Okay, now we have ended with this nice expression. Now if you take a look carefully at both sides of this equation, the left hand side of this equation is involving number 7, and if this m and j growing up, and that's mean the one is going towards the upper left side, the other one is going upper right side, never ever meet. Okay, so if you give, for example, m equals 1 and this one is 2014, if you give j equals 1, if m goes towards big number and j goes towards big number, that's mean the whole thing, it will not, that's mean the equality never occurs. So to maintain order and make the equation works correctly, so since we have this number, the whole number is an even, and this number is an even as well. Okay, so and 3 to the I is an odd, so the only odd on the left hand side of this equation is number 1. So in order to get number 1 equals to this one, we have to give I equals 0. Okay, this is the first thing, I equals 0. The second thing, if we don't give j equals 1 is a problem. Let's take, for example, j equal to 2. If j equal to 2, that's mean 3 square, I have 9. 9 minus 1 is 8. Okay, it's 8. By the left hand side of this equation become different number. Okay, because if m equals 1, for example, we will have 14. 14 equals 8, which is impossible. Okay, that's the minimum value. If you go more up, you will have the problem growing up. If you go in more up, you will miss the equation. You will never ever you have the solution. Okay, so the only condition that we have to fix this issue, to give m equal to 0 and j equal to 1. If we give m equal to 0, that's mean this one 7 to the m turns to 1. That's mean we have 2 is multiplied by 1, which is 2. Then the right hand side of this equation, as we have 3 to the I equals 1, as we mentioned before, I equal to 0, we will have 1 here. This term also 3 to the 1, if we give j equals 1, 3 to the 1, which is 3, 3 minus 1, which is 2, 2 equals 2. We have equality now. The only condition that we have to fix this equation to make the equation works in the perfect way, so we have to give j equals 1 and m equals 0. Okay, this is the only condition that we have to fix this issue. Okay, now I'm going to take this found fact and insert it into original equation to see what's given us. I'm going to use the first equation, so we'll have x plus 7 to the m will be replaced with number 0, which is 7 to the m turns into 1. J will be replaced with number 1, which is 3. Okay, so that's mean x equals 2. 3 minus 1, which is 2. So now I found x equals to 2. I'm going to replace x with its value into the original equation. Okay, now we'll have 3 to the 2n as an original equation. This m will be replaced with 0. This one is turned number 1 here, equals x equals 2. That means 2 square, which is 4. By taking number 1 to the right, I will get 3 to the 2n equals 4 minus 1, which is 3. Now I found the exponent. The exponent 2n equals 1. Okay, since we have n as a positive integer, this is impossible to have 2n equals 1. Okay, this is contradiction. Which contradict here? We contradict the parity of this one. We assumed b is even, is turned into the contradiction. That's mean b is absolutely an odd number. Okay, let's clean up this board and continue with solving our equation. So in the last board, by the way of contradiction, we have proven b is a odd. B is a odd. That's mean b equals 2m plus 1. Okay, I'm going to take this value and insert it into the original equation to see what's given us. I will have 3 to the 2m, I will have 3 to the n plus 7 to the 2m plus 1 equals x squared. By taking 3 to the 2n to the right hand side of this equation, 7 to the 2m plus 1 equals x squared minus 3 to the 2n. Okay, so this one is written on the form of the difference of two squares. I'm going to factor out this one. You will have x minus 3 to the n factor x plus 3 to the n. Since 7 is a prime number and the left hand side of this equation is a power of 7, that means the right hand side of this equation must be a power of 7 as well. That means this one will be written on this form as I did before. So the x plus 3 to the n equals 7 to the x, and the second equation will be written on the form x minus 3 to the n equals 7 to the y. Okay, so by subtracting equation number 2 from equation number 1, I will get 2 times is multiplied by 3 to the n equals 7 to the x minus 7 to the y. As we have here, x is strictly superior than y because this term is bigger than this term, as we have x as a positive integer. I'm going to bring this one down here. I will have 2 is multiplied by 3 to the n equals 7 to the x minus 7 to the y. So as I did before, I'm going to take 7 to the y as a common factor. I will have 7 to the x minus y minus number 1. Since this term is an even and this term is an even, 7 to the y and 7 to the y is odd. Since this term is an even and this term is an even as well, but 7 to the y is odd. Okay, so it's clearly we know which numbers we have. You cannot put 7 to the y equals 3 to the n because they are different primes. Okay, they are different numbers. Never ever 7 to the y equals 3 to the n. Okay, so that's mean this one was multiplied by number 1. Okay, that's mean number 1 is taking this one and the whole term is taking this one because this one is an even, this one is an even as well. So in order to make this equation in the balance, so I'm going to put 7 to the y equals 1. Okay, that's mean y equals 0. If y equals 0, this means 7 to 0 equals 1. That's mean y equals 0. I'm going to replace y with 0 here. Okay, I will have 7 to the x minus 1. And also, as I said before, if you increase x and n, 7 and 3, you will be going far away from each other. Okay, because they are different numbers, they are different primes. Never ever 3 to the n meet with 7 to the x, except one condition as we did before. We have to give n equals 1 and x equals 1. If x equals 1, that means 7 minus 1. 7 minus 1 will be 6. With this one it was 1. This one n equals 1, that means turn to 6 as well here. 6 equals 6. Because if we give one number more, for example n equals 2, I will have 9 here. I will have 18 here. Okay, because 2 is multiplied by 9. But here, if we leave x as is a problem because 7 minus is 6. I will have 6 equals to 18, which is impossible. And also if we give x equals 2, that's it turns into 49 here. 49 minus 1 is 48. 49 will have 18 here is a problem. So the only way to maintain this order and fix this equation and to give x equals 1 and x equals 1 and also n equals 1. This is the only condition to fix this equation. Okay, if I'm going to do so, that means I'm going to replace this found fact into this equation. Okay, x, by replacing n with number 1, I will get 3 here. By replacing x with number 1, I will get 7 here. I'm going through the first equation. Then I'm moving over number 3 to the right side. I will get x equals 7 minus 3, which is 4. Now I found the value of x, which is 4. Now I'm going to take this value of x and insert it into the original equation, which is this one. Okay, this is the original equation. I'm going to take this original equation here. I will have 3 to the 2n plus 7 to the 2m plus 1 equals x squared. Now by inserting this value of n which is equals 1 into this equation, and replace x with number 4 as I found before into this equation to find m. So this one I will have 3 squared, because n is replaced with number 1, plus 7 to the 2m plus 1 equals x squared, which is equals 4 squared, which is 16. I'm going to move over this 3 squared to the right. I will get 7 to the 2m plus 1 equals 16 minus 9, which is 7. Okay, now I found the exponent. This one equals to 1 as an exponent. So this one is telling us 2m plus 1 equals 1. So number 1, it will be cancelled out from the left and the right. I will be left with m equals 0. Okay, now I found the value of m equals 0. Now I found m equals 0 and n equals 1, and I found x equals 4. Okay, by going back to the original equation, we have b as a odd number. It was 2m plus 1. By replacing m with its value, I will get 2 0. I will get 2 is multiplied by 0 is 0 plus 1, so that means b equals 1. And a, it was 2n, and by replacing n with its value, I will have number 2 here. By taking these two values and insert it into this equation to see is verifying this equation or not. 3 to the a, which will be replaced with 2 squared, plus 7 to the 1. 3 squared is giving us 9, plus 7 which is 16, which is 4 squared, which equals x squared. Okay, I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.